Hey everybody. Today we're going to be going over Leetcode problem 1456, which is maximum number of vowels in a substring of given length. And in this problem statement, we have given a string S and an integer K, return the maximum number of vowel letters in any substring of S with length K. Um, and those vowels obviously are A, E, I, O, and U. In the first example, just to kind of understand what they're looking for here, our inputs that they gave us are string S, which is A, B, C, I, D, E, F, and then the K is 3. That's the given parameter. And one thing to note here is that it's the problem is them giving you a string as well as a constraint. So because of the reason that they gave us the constraint, one of the first things that immediately popped up to me was the sliding window technique. I know there's a couple of other ways to do this. I think you could use a hash map. You could throw a couple of other things at it, solve it a different way. But the first thing that stuck out to me and something an approach that I would kind of know how to use would be the sliding window for this one. And if you're not familiar with what a sliding window is, I have an example right here of A, B, C, D, E, and sliding window. And in this instance, in this case, sliding window, it's going to be a fixed length sliding window. Typically with sliding windows, you're traversing, whether it's a string or an array, you're traversing it, and you have your left side of the window, your left bound is moving in regards to certain situations that you come up in your problem, and then the right side is also moving depending on certain situations. But in this case, it being a fixed length, you know that it's going to move the same amount of times, or the same amount. Your window is always going to be the same length at every time you move. So you don't have to worry about thinking about any logic as to when to move the left and when to move the right. You're basically going to be checking the left and the right every single time, every increment. I don't know if that makes sense. I don't know if I'm explaining that very well. But visually, I know it makes a little more sense. So this is that same array that I showed you up here, the A, B, C, D, E. And the constraint that we have in this example is 2. And so basically what that means is we'll look at the first window, quote unquote, or quote unquote, which is A and B, because that's 2, that's length 2. And then on the next step of your window, it's got to keep the same length. So we'll take a step forward, and that's what this arrow is showing here. We'll add the C, and then we'll remove the A. And then in this problem specifically, when you do that, you're checking to see if when you're adding that C, is that a vowel? If it's not, we won't count it as a vowel in our problem. And then also you're looking to see when you remove the left bound and move it up, was that a vowel? Because if it is, you need to decrement the counter for that. Otherwise, leave it the same. So yeah, we can go into how to solve this, or how I solved this earlier. So the first thing we want to do that immediately stuck out to me was to initialize an array of vowels. In this case, well, I guess in every case, it's always A, E, I, O, and U. And then after we do this, we want to set up the first part of our window. So we'll set up the initial window, which would be I through K. So we'll say for I in range, and then we'll say K, whatever that value may be. And then we'll say if S at I is in that vowel list, then we will say cur plus equals 1. And that just reminded me, I forgot to initialize our other variables. So before we can do that, there's a couple of other things we need to add as well. That being the left side of the window, as well as your final answer, as well as your current sum of vowels variable, which we'll call cur. And we initialize all of this as 0. This might look a little bit confusing because typically people, when they initialize variables, they'll, like for instance, with these 3, they'll say left equals 0, answer equals 0, and then current equals 0. But in Python, there's a neat way to do this where you don't have to, if it's all going to be the same value, you don't have to repeatedly set them like that. You can just say left equals and then followed by your next variable, that you want to initialize, and then followed by however many more. And then at the end, just initialize them all to 0. So yeah, now that we have those, again, the left variable is for the left side of the window. Current is for our current answer, or aka the current number of vowels as we move through the array with the window. And then answer is always going to be our final answer. That'll be what we return at the very end. So here again, really quickly, so for I in range K, we're just setting up that initial first window and we're iterating through each one. And as we iterate, we check to see if S at that index is a vowel. And if it is, we'll increment our current vowel count so that we know how many are in there. And then after we get out of this initial setup, we will set answer to whatever the current amount of vowels is, because that's where we're at. We set up the first window and then we can step through the rest. So this is where we will bring in our right variable is what we'll call it, and this will be the right side of the window. So if you're looking at this window of 2 right here, this circle right here, this will be our left side of the window, and then this is your right side of the window, if that makes sense visually. So yeah, so we'll say for right in range, and we'll say K through the length of S, because we want it to run until the end of the given array. And then we'll say if, this is where the logic is going to come in, where you take that next step, and now you're checking to see if the next value is a vowel or not, and you're also checking to see if the vowel before that we're getting rid of in the window, or stepping past, it was a vowel or not, so that we could decrement the counter. So we'll go with the first one, and we'll say if S at right is in vowels, we will say current plus equals 1, because we now have a new vowel to take care of. All right, so now that we checked the right side of the window, the right bound, we can go ahead and check the left bound. And in this case, you might be thinking it might be if S at left, but it's actually going to be if S at right minus K is what's going to give us our left bound of the window value that we're leaving behind. And then this is what you'll use to say in vowels. And then now that I explained that out loud, it reminds me that we did not need this left side variable. You would need this in any other regular or any different sliding window problem, but in this particular one, we don't need it, just because we're checking for left using this right minus K variable. You could have used it in here in the initial window, but it wouldn't really make much sense because you're not necessarily moving the left or the right pointer in the window. So it could just get confusing if you do that. So that's why I just used I to set up the initial window. So yeah, we can get rid of that. That's my mistake. The only variables you need in this case that I used for this approach is your array that you initialize at the beginning, vowels, as well as current number of vowels variable that we named cur, and then as well as your final answer that we named ants. So yeah, now that you checked the left side of the window, if it does have a vowel, remember we're leaving that behind, so you can decrement the current vowel count by 1, since we're going to be leaving that one behind, and check in the next window. And then at the end of all this, you can say answer equals the max. Since we're looking here in the problem statement, it says return the maximum number of vowels, so we're going to use max. There is a min function, but in this case we're using max, and we'll say we'll either keep our final answer as what was set up in that initial array right here for this first iteration, or we will say update it to whatever's in there currently, the number of vowels, and this will change as we go through the different test cases. So it'll just choose the bigger of the two, and then that's what it'll set answer to. And then at the end of all of this, once you're done with this for loop, that means the window has finished stepping through each value in the array. So then we can just return answer, and then again, because we were using max, this answer at the end should be our final answer of a sub array or substring in this case with maximum vowels. So yeah, if we run this, we should see all green as long as I didn't forget to do anything. Yeah, so we passed the initial test cases, case 1, 2, and 3. So we can go ahead and submit this. I've already solved this, so We're going to submit it again just to show you guys what it looks like. So yeah, you can see 187 millisecond runtime. It only beats 29% of Python submissions on here, which isn't like the most efficient. So it's like I said at the beginning, this approach that I took isn't the most efficient approach. There's other ways to do it that would make it faster. Um, but again, that's like the beauty of programming, I guess, and it's why there's so much learning in this, is that everything can always be done faster, more efficiently. But yeah, this is just the approach I took. So for now, to show you guys as an example. But yeah, that's how you solve the maximum number of vowels in a substring of any given length. Okay.